For hundreds of years, engineers have been trying to master ways to move through our seas, largely by the use of spinning propellers that push water backwards and therefore the ship or submarine attached forwards. But for millions of years, nature has been mastering this too, using a different method. And engineers at the University of Essex are investigating one member of the underwater population that might have got it right.
The fish motion has different mechanisms, but one of them is the S motion, by bending the body and the tail to generate the force, propel itself forward.
The S-like movement of certain fish sees most of the power coming from their tail. As the tail moves one way, the body curves in the other direction, and the surrounding water falls off the edge of the body and is pushed backwards. As this is repeated from side to side, water is constantly moved backwards, and the fish moved forwards. This is what the team at Essex have tried to replicate by designing robotic fish. Their initial fish contained 4 concavely linked joints powered by electric motors to accurately mimic this movement through the water. But movement alone isn't enough, as the fish need to be aware of their surroundings, so that after all this work they don't simply crash into a wall or piece of coral. And this requires the use of sensors.
The sensor for object detection is infrared, only looking for 30 to 40 centimeters in front of the fish. We have depth sensor, is pressure sensor. We calibrate the depth, then we can monitor the fish location. We also have gyroscope inside to maintain the fish balance and posture.
But whilst the team's design moved beautifully around tanks of water, their next stage faced many more challenges, as they adapted their fish to detect environmental pollutants, not in a tank, but out at sea.
We have done a lot of new design from the aquarium fish to the sea fish, because we have harsh environment to work with now in the sea. As we know, we have the bigger current in the seaport. We have the waves generated by sea or by the big ships. So the robotic fish have to have the energy to against all this kind of disturbance, and which is also dynamic change and totally uncertain.
To cater for these demands, the outer material of the fish was changed to carbon fibre for its strength and lightweight characteristics, to allow for the weight of the larger motors and batteries that would be needed to power the fish against waves and currents. This also resulted in a larger size, going from 0.5 metre to 1.5 metres, tripling the size of the fish. But another crucial factor was the need to simplify the design by reducing the number of joints.
First version in the aquarium, we use 4 or 3 motors to generate the S motion. But for the sea fish, we build up. We use only 2 joints to simplify its motion and to actually handle the harsh environment as a high priority.
A final fear when letting loose schools of robotic fish out at sea is the concern that they may never return or get lost at sea. The usual method of navigating and monitoring devices such as these is GPS, but these signals cannot be detected underwater. The solution? A tailor-made underwater system using sonar.
We put the sonar beacons surrounding of the port, just like a satellite signal. And the sonar beacon send out the signal. And each fish has a receiver to figure out the time of the signal from the beacon. And then doing the calculation, triangulation more precisely, to locate himself.
The final designs will use these sonar beacons to calculate their location in the same way as GPS systems, as well as allow the fish to communicate with each other as they collect samples from their surroundings and test for oil leaks and other water contaminants such as dissolved metals. Unlike propeller-based systems, the fish shouldn't generate turbulence behind them, resulting in an undisturbed environment, with fish and robots living as one. The first trial of the fish as environmental police will be in Port Gijón in northern Spain next year, as the battery-powered fish will go out each day to do their day's work and then navigate back to base each night in order to recharge, just like the rest of us.